The current project what we are doing is smart greenhouse, for which we have to generate information regarding soil moisture, temperature, light intensity, and any other flies are detected or not. To do all these things, we have taken different sensors, and we have taken node MCU connectivity for the current sketch, and using node MCU we have connected all the sensors. So here you can see this is the DHT11 sensor, which is the one which helps us to get the temperature as well as humidity content in the environment. And here we have another sensor called soil moisture sensor. So with the probe, it will come with a probe. So by this probe, if we put into the soil, we'll come to know what is the moisture content present in the soil, based on which if it is required with the water, it will pump the water through the pump which we have connected. If it is not required, based on the soil moisture, it will be not pumping the water, through which we have a connectivity. And you can see that we have given an analog. We are accepting the analog input from the soil moisture sensor. It is connected only one analog pin of your node MCU, so which in turn giving an output for the relay connectivity, to which the pump is connected. So this is how the connection is made for your soil moisture sensor. So coming to your next thing is the LDR sensor, that is light detection. So you can observe that as and when light is not there, the light will glow. This we have a connectivity. So if any electricity, like if light intensity is less in the greenhouse, this we have an additional light connectivity, that is blue indication is being given, that will be acting as a light now. So as and when I release, the light is detected, so the LED goes off. This is how it works. So now we can see here, this is a motion sensor detector. So as and when there is a motion, that will be detected. Here it will be sending a message to the serial monitor. So these are the different sensors what we have connected, and as and when the initiation, if any changes happens in the sensor, so this relay gets initiated, and in turn the fan and motor gets activated based on the requirement. So let us see the code part. So here we have designed all the pins. You can observe that moisture pin is at E0, motor pin is at D0, with the different intervals we have given, and status pin, digital D6 pin for your node MCU sensors, PIR sensor. D7 pin is also used. Different pins are used in different part, and each and every line of the code is given with a comment, so that it can be easily analyzed. So here, once I'm done with the code, we are just uploading that code to the node. Upload. So you can observe that the sketch is getting uploaded, that is compiled and uploaded. So now previously it was also working, that we had seen that soil moisture sensor and this one, and we can show the result even in the serial monitor. Serial monitor will be the one which will be getting the information, which is communicating through the common port, which is connected in this system as 18. It goes on varies. Common port will be communicating with. So you can observe that soil moisture is 32.994%. It's a percentage. We have given a percentage formula. So since of which it is not switching on, motor is not switching on. So as and when I remove it, the moisture content will be reduced. So you can get a message called motor on signal. See that there is a motion detected and motion absent. Every message has been specified over there. There is a humidity percentage and temperature data. So I have placed my finger on the temperature sensor, which increases the temperature. Previously it was less than 29.30 degrees Celsius. Now it is 29.3 degrees Celsius. So that's how it works. So now since we have shown you that relay gets activated, see there is a blink in the LED as in when the light is light sensor is availability and not availability. So the intensity of your light increases the temperature as well, for which to reduce the summer temperature we are going to switch on the fan. So this requires an additional supply, for which we are making a connectivity, this additional supply connectivity. So as in when I give a supply connectivity over here, fan gets switched on. An additional supply is even required for the motor. So now you can see that water is pumping over there, that has been observed. So once I leave it, it goes off. This is how it works. So if not, you can observe that moisture, as in when the moisture is less, that is the probes are removed. Since the water content is more in current location, so it is not giving moisture less. So once I remove the probe, so it is getting motor on condition there. Okay, that's how it works.